Hi guys, and welcome to the opening video for a new section for the Further Maths 3 and 4 course over here in Australia. Now don't worry about it if you are watching from other countries. This video is as much for you as anything if you're looking for a review of parallel lines. Now it is great having you here. I'm Darren Maths Guru. If you are new to my channel, welcome. If you can do me the honor of clicking in that bottom corner the doohickey to subscribe. Subscribers literally tell me that you're out there watching and mean that I'm not sitting in here talking to myself. If you haven't already found it, mathsguru.com has this video, downloadable nights, time-coded section videos. It'll have exam questions, VCAR questions, the works that I cannot put over here on YouTube. Head on over there, the link is above. Now, as I tend to do, I always start with what I'd like you to be able to achieve by the end of this lesson. And as this is a review, I'm very much hoping you'll find out what alternate angles are, corresponding angles, co-interior, and all the things that are listed above me. And I also like to start with a bit of a recap of learning, okay? So if you're new to these videos, at least you can find out what the previous ones were to try and work out whether you want to watch them again. So as it's the first module, pretty much there's going to be new stuff. If you can't remember that we were doing this from sort of year 8 and year 9 onwards, again, don't worry about it. If you can't remember it, that's the point of this video. Now, I always like to have a bit of a strange approach to mathematics. I do things slightly left field. And so in this situation, I'm going to call it the Maths Guru approach. And you can probably see those 4 rather large letters, FUZX, which I call FUZX. Yes, I'm not trying to be rude, and I do promise you that they actually stand for something. And they help me remember which of the rules for parallel lines we're going to deal with. I suppose the first thing is, though, let's just make sure that we are aware that parallel lines are expressed like that. They will have 2 lines with arrows pointing either to the left or to the right. And what that means is there are 2 lines there with exactly the same gradient, don't worry about that so much, that will never, ever, ever meet. And for maths, what we tend to like to do is we tend to like to put lines through them and then start talking about angles in corners and all sorts of exciting stuff, which is what this video is about. So parallel lines, there are a couple of parallel lines, but inside those parallel lines, there are in fact 4 different rules to help us find any of the angles that we need to. Okay, so let's start with the easier one here, the X rule. Now, you cannot use my FUZX in a further maths exam. I'm really, really sorry. I'd love for the exam board to suddenly try and say, this year we're going to involve the use of FUZX, but we have to remember that the X rule is called the vertically opposite rule. Now, why do we call it the X rule? Because funnily enough, here are some X's. Now you're going to turn around and say to me, well, they aren't parallel lines. I know, but I'm going to show you some X's in some parallel lines in just a moment. But what is important to know is that angles that are vertically opposite, and by that I mean this angle here and this angle here, are exactly the same size. Now what that also suggests is that this angle here and that this angle here are also exactly the same size. So to make that sort of more formal, the dot is equal to the dot in size and the square is equal to the square in size. So if I had this here and I told you that that was 32 degrees, I can actually now find all of the other angles here. So first things first, I now know that let's write that down at angle A. So A now must be 32 degrees because of the vertically opposite rule. But I suppose the question I'm going to ask you is, can I now find the angle B and B? Well, there are 2 ways of doing this. First things first is to know that we know that angles all the way around a point, and this thing here is a point, add up to 360 degrees. And so I could turn around and say, well, 360 degrees minus 32 will give me 296 degrees. Well, that's the size of both B and B added together. So I would then need to divide that by 2, which would give me 148 degrees. That's certainly one way of doing it. I tend to think that's really quite challenging. What I like to do is remember that, in fact, I have a straight line. That is a straight line. And what do I know about angles on a straight line? They add up to, oh yes, 180 degrees. So actually, angle B is simply equal to 180 degrees minus 32 degrees, which gives me 148 degrees. Same answer, probably a slightly nicer way of doing it. So there is my X rule. We're done. What about the next one? Let's have a look at this one here, the U rule. And again, you're going to turn around and say, where is the U? Well, what I do is this. There is a line, and there is a line. Are they parallel? I should Coco, and if I draw a line like that, do you see the U? I do see the U. There is a rather interesting U. So knowing that, there is a rule that says this angle here, let's call them A and B, which cannot be the same size. Hopefully you're looking at that going, oh no, they're definitely not the same size. We know that angle A plus angle B is equal to 180 degrees. Now, yes, the official name here, ladies and gentlemen, is that they are co-interior angles. Co-interior, they add to 180 degrees. Now, again, in maths, we can try and trick you because there's a line and there's a line and there we go. Now, there's my parallel and there's my parallel. And I'm going to say to you, where's the U rule? Now, hopefully you can see that there is a U, but it's just on its side. And so with my U being there, I now know once again that if that's angle A and that's angle B, they both sum to 180 degrees. Yay! Let's do a quick example. Toof, toof. I know that this angle here, let's say, is 60 degrees, and I want to find angle B. How am I going to do it? Well, I know that angle B is equal to 180 degrees minus the 60 degrees, which gives me 120 degrees. So, X and the U rule. Fabulous. What about the next one? The Z rule. Z for Zorro. And if you're too young for Zorro, don't worry about it. A stranger guy ran around in a cape with a sword and kept cutting Zs in people's clothing. I never really understood why. But anyway, he was a bit of a gigolo. So the Z rule is, funnily enough, just that. There we go. Once again, let's draw my parallel lines, and I'm going to draw a line through it. Can you see the Z? Hopefully you can see the Z, which is there, there, and there. So there is my Z, and the rule states that this angle in the corner of the Z and that angle in the corner of the Z are exactly the same. So zup, zup, zup equals that. But I suppose we need to make sure that we realize that this has an alternate angles rule, right? So alternate angles, the angles in the corner of the Z. But I'm going to show you there is a bit of a trick here. Now, that's actually the same diagram, yes? But there is also another Z. And it's this one here. Now, you may not necessarily think that's a Z, but just imagine I've taken that letter Z and I've pulled the corners so that it sort of stretches out a bit. The rule still states that the corner of the Z, that this corner here and that corner there, are exactly the same size. Because you can tell we're going to trick you on this one here. But the Z rule is lovely. And finally, the F rule. And again, it is no surprise that if I was to draw two parallel lines, and unfortunately my screen just decided to catch out there. There we go. Can you see the F? Now, if I take that line out and just do this, well, there was the Z. But all I'm going to do, funnily enough, is I'm just making the line longer to give me an F. Can you see the F? I can indeed see the F. There we go. There is an F. And the rule states that the corner angles of the F are once again exactly the same. Now, the official rule for that is corresponding angles. But again, there are other tricks to this. I'm going to draw another F. How many Fs can you see in this diagram? Because I can actually see another one, which is this one here. It's just the backwards F. But it also turns out that if I was to have this, then there is an upside down F as well. And there is also a back to front upside down F. So there are lots and lots of Fs in diagrams, and do not swear at me, please. But those angles in the corners of the Fs are exactly the same. So we recap. We've got the X, opposite the same. We've got the Z, corners are the same. We've got F, the corners are the same. The only one that's different is the co-interior. All right, so we know what parallel is. We've decided that parallel lines are given by lines that will never ever meet. They have the same gradient, the same level of slopiness. And that's really important. If your diagram does not have parallel lines on it, if it does not have those two arrows, then the chances are it's not parallel. Okay, what about perpendicular? Love perpendicular. Now, perpendicular lines are actually lines that meet at one point, but that are at right angles to each other. So there is a gradient, let's call it gradient M1, and this thing here will have a gradient and we'll call it M2. Now, this is a little bit outside the further maths course, but we know that the gradients of those two are actually linked by a special rule. That's M1 times M2 is equal to -1. We'll come back to that undoubtedly in a later video. But the important thing to notice here is that the gradient of one is met by the gradient of the other, but at a right angle. That has to be a right angle there for this to work. Now, language is key in mathematics, and sadly, the one that I'll be honest with you, I can never remember the difference between complementary and supplementary angles. I don't know why, my brain just does not want to remember it. So if you have an easy way to remember complementary and supplementary too, please leave a comment below and let me know how you remember it. Who knows, I'll actually name it after you. So complementary angles are simply angles that add up to 90 degrees. So if I had a right angle here and I split that off into, let's say that was 60 degrees, this would obviously be 30 degrees. And so this angle here and that angle there would be complementary. Yes, they would. Supplementary, as it says there, are angles that add up to 180 degrees. So once again, if you have a straight line and this angle here was 70 degrees, that angle there would have to be 80 degrees. And then as such, this angle here and this angle here, when added together, would be supplementary. Now, how are we going to use these? I am delighted that Cambridge Essentials or Cambridge Further Maths Textbook, or Cambridge in fact, have allowed me to use their examples throughout my videos. Thank you so much. They are awesome books and awesome examples. Here is an example here. Now, this one deals with numbers. We're going to sort of ease you in gently. Numbers, but sadly, by the time you get to Further Maths and having done previous modules, you're going to have to start dealing with algebra. There's no two ways about it. Algebra is going to come in. Yes, this has got letters in it, but let's see what we can come up with first. So find the values of the pronumerals in the diagram shown. Well, there's my diagram. They've given me one angle here, 65 degrees. And I'm going to start looking for F, U, Z, and X rules. Well, as it turns out, I can see I've got an X in here. And so I now know that that angle D is got to be 65 degrees. So I'm going to write down A, B, C, D, and E. And I know that, what did I say, angle D was equal to 65 degrees. Let's rub that out and let's stick with my reference angle there. What do you notice about angle E? Well, funnily enough, I've got a straight line. So I know that these two angles here must add to 180 degrees. So I know that angle E is equal to 180 minus 65, which gives me 115 degrees. Well, if I found angle E, then I must be able to find angle C. Why? Because there is an X, and I know that these two angles here must be exactly the same. Do you notice how I'm doing this? I'm just saying, well, angle C then must be 115 degrees. Well, I found all of those. Awesome. What else do I know? Well, can I see any other letters in here? Well, I happen to see a U rule. Ah, look. I've got a U rule. I know that C and angle A there must add to 180 degrees. So I know that C is 115. So A must equal to 180 minus 115 degrees, which is 65 degrees. And can I find the angle B? Well, I should hope so, because once again, I've got this on a straight line. And so I know that A and B must add to 180 degrees. And so B is equal to 115 degrees. Now, this is just one way of going around this. There are lots of ways of doing it. There are F rules, there are X rules, there are Z rules. Again, can you see the Z in this? There's a Z there. So I automatically, the D and A had to be the same value. There is a backwards Z here. There are so many different letters in there that you could have worked out. But I think this question is an awesome opening to example 2. Because as I've said to you a moment ago, we are going to start using algebra in this stuff. It's the way to try and trick you. But you can do algebra. This isn't a problem. So find the value of the pronumerals in the diagram below. So we have this angle here, obviously, and we have this angle here. So I'm going to ask myself the question, F, U, Z, or X? Well, hopefully all of you can see here that there is, in fact, one of those elongated Fs, which tells me that the two corner angles must be the same. And so I now know that X plus 10 must equal 2X minus 50. Well, it's now realistically that FUZX has finished. Oh, sad. Why? Because we now go into algebra. And what I want to do is collect all of my like terms. I've got two X's there, but I've got an X on the other side. So I'm going to move this X over here. And in the same way, I have a number there and a number there that I'm going to swap places. So the 2x stays where it is. A plus x becomes a minus x. I have the plus 10 already there, and that minus 50 becomes plus 50 over here. And 50 plus 10 is 60. 2x minus x is x, so I now know the value of x must be 60 degrees. That one line here, this here was your parallel line stuff. Didn't need to go any further because the rest of it was algebra. And this is where maths tends to throw people, because everyone else there thinks we're just going to ask one question to deal with FUZX, like example 1, and we're never going to cross over any other topic. And I'm really sorry to say that's actually not true with mathematics. Here we go. It looks a little bit more complicated now. We have x's and y's. But the good news is we can build on the previous knowledge. You see my little sort of elongated z, which means that this angle here and this angle here are exactly the same. So I'm just going to repeat what I did from that first example. Let's say that 2x, what is it, plus 80 is equal to x plus 100. Right, I'm not going to worry about y for the moment. I'm just going to solve this. Well, collecting like terms, I want my 2x's and my x's together. So we're going to say that we're within 2x, and we're going to take away an x from both sides. And then I want to get rid of this plus 80 to move it to the other side. So I'm going to take away 80 from both sides, but add on the 100. So 2x minus x gives me x, and minus 80 plus 100 gives me 20. So I now know that x is 20 degrees. Now it's at this moment I would generally redraw my diagram to make it a bit easier, because I now know what that angle is. I've got x plus 100, which gives me 120 degrees. And in here now I have y plus 60. So let's see what we have now. Well, we know that those two angles added together give me 180 degrees. Why? Because I've got a z. Sorry, I've got a u. I'm getting all confused with my letters. So there's my u, and so I now know that y plus 60 plus 120 must give me 180 degrees. Okay, so that's y plus 180 is equal to 180, and so taking away 180 from y from both sides actually gives me the value of y as 0. There we go, bit of a trick question there, don't you think? I do too. All right, so there we go. So those are the three questions from the Cambridge Central textbook, and I'm pretty much finished this particular video. Ooh, there was a lot in there, but basically parallel lines, lines that never meet, FUZX, co-interior, supplementary, alternate, and vertically opposite, with a little bit of complementary and supplementary thrown in. Thank you so much for watching. If you have made it to the end of this video and are able to do so, please will you subscribe and let your mates know that these videos are here. Hopefully it's useful. It's the start of a much bigger module on angles and Pythag and all sorts of trig and all sorts of stuff. And hopefully you'll stay for the whole series. It's really good seeing you here. Thank you so much. I'm done. This is the Maths Guru signing out until I see you in our next video. Take care. Bye.